Good morning. In this video we're going to continue to discuss the Pythagorean Theorem. Specifically we're going to look at ideas or concepts about the Pythagorean Theorem that help us find area and perimeter for squares. We know from our work in class the Pythagorean Theorem just tells us that if you have any right triangle, a times a squared, plus b times b squared has to equal the longest side, c times c, or c squared. When you get to high school, you're going to keep working with the Pythagorean Theorem and try to prove that for any right triangle, a squared, or a times a, that's represented by this square here, plus b squared, is b times b, this blue square here, is equal to c squared, the longest side. So if you put a square attached to each leg and the hypotenuse, that can represent a squared, or a times a, because squares have the same length and width. This can represent b squared, b times b, the area of the blue square. And this square, the bigger one attached to the hypotenuse, c times c, the area would represent c squared. So we know in theory that if we add up this square's area plus this square's area, the two legs, it should be the same thing as the hypotenuse's square area. Today we're going to focus on how we can find the area and the perimeter when we see squares attached to this right triangle. First off, they say in the figure above, all three blue boxes, they're perfect squares. They want to know what is the length of line segment XZ. That's what this means right here. When we see a line right over two letters, in geometry that tells us the line segment that connects point X and point Z. Well, I know that the blue box is a square, and I know that the area of a square is equal to side times side, or side length squared. So here, if the area is 25 square inches, I can take the square root of 25, and that tells me the area has to be coming from a side length of 5 times 5. So I know that XZ is actually equal, XZ has a measurement of 5 inches, because 5 times 5 gave us this blue square with an area of 25. Because of that, we also know that z to y, if we take the square root of 144, we know that z to y, let me go ahead and fix that, z to y should have a length of 12 inches. This should look familiar to us. Some of us have seen the 5, 12, 13 triangle before. X to y should have a length of 13. We're going to see that. What is the area for the unknown blue square? Well, if a squared plus b squared has to equal c squared, all we'd have to do is add 25 plus 144. That gives us 169 square inches. So, again, one more time, if a squared, this square, plus b squared has to equal c squared, then 25 plus 144, the area of these two squares has to be equal to the area of this square. And we know if it has an area of 169 square inches, let me write that out, then the side length for x to y must be equal to 13, because 13 times 13 is what gave us 169. So, if they ask me for the perimeter for the unknown blue square, this big blue square, what is the side length for the blue square? 13 inches. So I would just do 13 inches times 4, because each side length is 13 inches for the blue box. 13 times 4 gives us 52 inches for the perimeter of the big blue box.